Okay, so this is going to be for Miss Cat's Unit 4 Test Accelerated Algebra 2. And the first thing we're going to review over is arithmetic series and sequences, as well as geometric series and sequences, and infinite geometric sums. That's the first part. So, arithmetic series, you're going to remember it as Sn is equal to n over 2 times, I'm going to make this special actually, a1 plus an, or you could say Sn is equal to n over 2 times 2a1 plus n minus 1 times d. Now, this is a1 is the first term, right? And these two are exactly the same. So that's a nifty thing to learn. The second thing is arithmetic sequences, which is an is equal to am plus m minus n times d. D is the difference between two numbers in the sequence. And so let's say we have a2 minus a1, that's equal to d. And an and am could be any two numbers. Any two numbers. And in stigma notation, we will have a let's say we're gonna have a number up here, x, n is equal to whatever, right? And then on the side we're gonna have 2x plus 2. That means that the beginning variable, which is whatever this is, I'm just gonna say for one example, like 1. So the first term would be equal to 4, right? And then you go on to the second term, which is equal to 6, and so on and so forth. And the difference will always be 2, right? Now I'm going to cover geometric sequences and series. Let's start with the geometric series. For the geometric series, you want to remember S of n is equal to a1 times 1 minus r to the n power divided by 1 minus r. And a1 would be your first term, n being the term you're trying to find, and r being the ratio. And for the geometric sequences, you're going to have to remember an is equal to a1m times r, the ratio, and n minus m. N minus m could be two different terms. The ratio, in order to find the ratio, you want to do a2 divided by a1. That's going to get you the ratio. And in stigma notation, let's say we have something like the same concept here, and equals whatever. Instead of that, we're going to have on this side 2 to an x power plus maybe something like that, right? That meaning the first term would be, if this was 1, right, this would be 4 as the first term. And the second term would be, if this was 2, put into here, it's going to be 6, which it seems like it's following the pattern so far, right? But then when you get onto 3 for example, you'd get 10, right? Which doesn't follow the rules. Next, what I'm going to do is, next I'm going to let's talk about the sum of an infinite geometric series, or an infinite geometric sum. This would be S is equal to A1 divided by 1 minus the ratio. Right. Well, there are two types of geometric sums. There's diverging ones. And then there's the converging ones. The converging ones is when the ratio, the absolute value of the ratio, is less than 1. The diverging ones are when the ratio, the absolute value of the ratio, is greater than or equal to 1. Now, only when you have a converging sum, infinite geometric sum, is when you'd have the actual sum, right? So you'd only do this if it converges. And let's talk about another unique thing I want to talk about. Let's say we were to have in stigma notation 10 on the top and is equal to 2, and that's 3, just a solid number 3, right? We're first going to subtract the top number, 10, minus the bottom number, 2. And that's going to get us 8. But remember, we also have to count the first one. So you have to add a 1. And you have 9. So 3 times 9 is equal to 27. Moving on to something recent that we just learned. And that is A equals P E R T, which is also the compounded interest compounded annually, right? Compounded interest. P is your starting amount, and E is E, and this is the ratio, which is given to you in a percentage, right? So let's say you earn like 8% annually. This would be 0.08. Time is just time. And this is for annually. This is annually, right? If you want to do quarterly, you're going to have to multiply 4 times the time in addition. If you're going to do monthly, 12 times time, and so on and so forth. And that's the first one. And the second one is we're going to talk about exponential growth and decay. AT is equal to A1 plus or minus R to T. Now this looks very similar to the geometric sequence. In fact, it is really similar, except you don't have the minus 1 up here. So decaying, you would subtract, but in order to get the ratio, usually you get a percentage, like let's say 10%. You convert that into fractions, which is 0.1. And you would have A times 1 minus 0.1. Let's say if you were to lose 10% every time, right? And that'd be A times 0.9. If you were to increase like that, then you'd have 1 plus 0.1 times A to the T, which is equal to A 1.1 T, right? Now I'm going to talk about half-lives. So with half-lives, you're going to have N T's equal to N E negative KT. And this is the half-life up here. Half-life time. This is also the known as a half-life time. In order to find out the half-life time, you're gonna take the time it takes to get half-life in the first place. So let's just take 0.5, right? That's equal to 1e times whatever k, right, times the time that you have for the half-life. Like, let's say they give you the half-life of this much time. It takes this much time to become half. You're gonna solve for the k, and once you do, and you're looking for the time it takes to decay to a certain period, another time, you'd be able to place this k into the equation, right? N would be your starting amount. Now I'm going to talk about logarithms, and these are the rules you want to remember. Log b a is equal to log a over log b. This is essentially log base 10b log base 10a. You also want to remember that if you were to have log b to the x power, it'd be the same as x, since these two would cancel out, right? These two would cancel out. And in this situation, since the x is over here, you could also move it over here, and it'd be this essentially just x times 1, which is also equal to x, right? We're gonna, same thing as this. And I use that principle because of this one, where if you have any log base whatever number of whatever number to the x power is the same thing as x times that log. And over here, where you have b raised to the log of bx, you can just cross that out and be x equal x. And over here, you want to remember that log b of any number plus log b of any other number, that's the same thing as multiplying. You're going to remember that. If you're subtracting, it's going to be dividing, right? And it's the same thing goes for natural log. So if you were to have natural log, so let's say natural log e, which is literally equal to log e, which is just equal to 1, right? Now, important things you want to know about log is that if you're using it for like exponential growth, exponential decay, and interest, you want to make sure that if you're dividing and the log on the bottom of whatever number, right, it doesn't matter what's up here, right? It doesn't matter for now. If you have it less than, let's say like less than x or something like that, or x would be a bad example in this case, less than y. If this number right here, if this log on the denominator, if that is less than 1, if that is less than 1, then you're gonna switch the symbol, right? You're gonna flip-flop the symbol around. So then it looks like, then it looks like this, right? And that's all that you need to review. Good luck and try your best. Thanks.